basically, as you go along over history, you've got things like wood, you've got material sciences. We keep innovating and replacing things that we normally got from the earth. And then we came to energy solutions. And now we're finding that, no, we don't have to burn fossil fuels. We can capture the mechanical motion of waves and wind and the solar electromagnetic energy from the sun. And the problem is storage. And that's where these base metals come as probably the last thing that the earth has to offer us. Now, the idea of going to the bottom of the ocean, a place where I've spent quite a bit of time actually, to acquire these metals makes all the sense in the world to me, because the concentrations are much higher. You essentially have 3 or 4 mines in one. On land, you've got to go to a nickel mine, a copper mine, a manganese mine. And these nodule formations are remarkable in that they have acquired all of these metals. It just doesn't happen on land. You don't get this coincidence of accumulation of metals in one place. So already you've got this efficiency of mining sites happening. And then the question then comes, okay, what are you doing to the environment? And you can look at that 2 ways. One is the biodiversity loss or disruption, and then the other one is the ecosystem function. And in both cases, the ocean scores better than land, from my point of view, in terms of the disruption that you cause. The place in the ocean where we're finding, by the way, these nodules occur in various formulations all over the planet, and we're still learning exactly where they are and what the different constituencies of them can be. But the ones that we're focused on right now are in an area called the Clarion-Clipperton Fracture Zone, it's an area of the high seas, which means that everybody on the planet owns it, in the sort of about 1,000 miles west of Mexico. And the bottom of the ocean there is fairly flat. And if you were to drive around there in a submarine, which I have done, it looks like a kind of a flat desert. There's just a lot of sand and this fine sediment, and then these nodules have formed in the bottom sediment. So we just pick them up. There's no blasting. There's no chemicals used, and bring to the surface, and then turn them into. We grind them and send them through a couple of patented processes where we end up with very little to no waste. So it's a bit of a long story, but the short story is that when you go on land, you're essentially releasing carbon from forests and from the soil. You're displacing tigers and lions and bears. Oh my! I mean, there's these rainforests have a lot of these megafauna, these very large charismatic megafauna, which you don't have in the deep sea. You do have some remarkable fish and worms and sea urchins and things like that, which I don't want to diminish because I'm a marine biologist. I love those guys, but it really is it's a different complexion altogether when you're down there. We're not talking about vibrant coral reefs. We're not talking about herds of tuna or whales. We're talking about a very deep, dark, very monotonous kind of a place. And the impact from an ecological point of view is localized. It's not going to spread throughout an ocean basin and cause all kinds of change. It probably is going to settle down after, well, certainly the initial disruption of picking these things up will settle down after a few days or weeks. And the longer term disruption, if you can even call it that, would settle down certainly within months. Now, the nodules themselves take many millions of years to form, so you're not going to recreate those, but there's plenty of them there, and the habitat in which they exist, in which they provide homes for other animals, will still exist down there on the bottom of the ocean. So it's an intervention that will have long-term consequences, but compared to land, it's an order of magnitude less.
Welcome to the Collective Insights podcast, where we explore topics and technologies revolutionizing human well-being. Today we have Gerard Barrand and Dr. Greg Stone from DeepGreen join Daniel Schmachtenberger to explore how to collect the resources we need to survive while protecting our environment. Make sure to subscribe to Collective Insights wherever you listen to podcasts so you don't miss an episode.